Our last keynote of this day is Daan Ongkowidjojo from SWECO, Belgium.
As Europe's leading engineering and architecture consultancy company, SWECO has great opportunities, but also responsibility to lead the way in transforming our societies in a sustainable direction. Within SWECO Belgium, Daan Ongkowidjojo has been working on projects concerning district heating networks, hydrogen economy, power to gas, hydrogen for transportation and smart grids, but also on biodiversity in business parks, collective water management and circularity. Since 2019, he is leading a team of experts and engineers active in climate and energy transition in the public sector. Together with his team, he has been guiding several communities and cities to a pathway for a more sustainable future. In his keynote today, he will give us a view on the evolution in smart communities design at SWECO. Real cases in Stockholm and Ghent illustrate the main principles integrating the current energy context. Daan, the stage is yours.
Good evening, and thank you for the nice introduction. You can say Daan, it's enough, you don't have to add the Ongkowidjojo. And thank you also for the opportunity to give me the chance today to share with you maybe a story that is a little bit different than the stories you heard already today. What we're going to do today is, or this evening, is we're going to take a step back from the building level, and we're going to look at the broader context of the energy transition that we're in at the moment, and how we translate this to a community level. And in Europe, we have this energy transition going on, and we see different speeds in different countries. And this has a whole lot of different reasons, but I would like to show you a very schematic summary of how the energy infrastructure in Stockholm, Sweden, is evolving throughout the years. And as most cities in Europe, they started off with a well-developed gas and electricity infrastructure. But already in the 1950s, they decided to invest in district heating networks in a collective energy system that is still operational today. And even in the 90s, they added their district cooling systems. The district heating at the start was fueled by waste, by biomass, also electricity. But they have this infrastructure there that is ready for a transition to more sustainable sources. And the interesting thing about this is that they have, since the 50s, already a collective heating system available. They have a different mindset than we have here in Belgium about district heating and heat as a service. If we compare this to Belgium, in Sweden they have over 7,500 kilometers of district heating network up and running today. And it pains me to say that we in Belgium, we don't even come to 100 kilometers of district heating network, so we have a big gap to fill in there. But at the other hand, also Stockholm has its own challenges today. It's not because they made the choices 50, 70 years ago that they already made the transition today. But you see that they have some kind of head start in comparison to Belgium. And what you see now in Stockholm is that when they look at the city, they don't just see a consumer anymore, but they're looking for opportunities and ways to also harvest energy in the city. So a city is no longer a consumer, but it becomes the prosumer. And in addition to that, we also have the industrial sites surrounding often densely populated regions. These industrial sites, we should not consider them just as energy consumers, but we should make them evolve them to energy hubs, which helps transitioning their surroundings. If you go back to Belgium, then in most cases when there is a debate or a dialogue about energy, in most cases it is a debate about electricity. The debate about the power plants, what we're going to do with the power plants in the future, the debate about how are we going to accelerate the development of the renewable energy production. But if we look closer to the final energy consumption by source in Belgium, and on this diagram, you see that electricity is highlighted. Then not even 20% of our final energy consumption is about electricity today. This is going to change due to electrification, but today it's not even 20% of our final energy consumption. And I'm not saying that the debates about electricity are not important. No, at the contrary, they are important. But we cannot lose sight of the petrol products and the natural gas in our final energy consumption. There lies a very big challenge for us to take this into the transition, but not only a challenge, because if you look at it combined, it is 75%, it's 3/4 of our final energy consumption. There lies, for me, there lies also the biggest opportunities to make a significant impact on, in the energy transition. And if we look at buildings and at the conventional heating systems, it is mainly natural gas today, so that's why we think that the discussion should not only be on electricity, but we should very much focus on petroleum products and natural gas. When we see the transition to 2050, we have three main trends, main future energy trends. And the first one is energy efficiency, and I think we all can agree that energy efficiency is very important, and we can decrease our overall energy consumption. But at the same time, we get an increase of electricity demand due to the electrification. And electrification itself is a very good evolution, because in most cases the technology is more efficient. It's a technology that is easier to convert to green energy sources. But we have to quadruple our energy production in Belgium today to meet the future demands in 2050 due to the electrification. And not only this, we have to increase the share of renewable energy production, because today, if you look at the share of renewable energy production today in our total energy consumption, it only makes out 3.4% of the final energy consumption. So if you look at, if we zoom in into the renewable energy production, we see that 70% or more than 70% of our renewable energy production is produced by sun energy and wind energy. So this is also where our focus should be when accelerating the development of renewable energy production. But we have to take into account that these energy sources are variable, they are more decentralized, which means that this leads to a different kind of energy model than we are used to today. And we call this a paradigm shift. Like today we are in an energy market and an energy model which is mostly centralized production, and you have production, you have consumption. And generation of energy just follows the consumption. But with the increase of more and more renewable energy production, which is variable, which is decentralized, also with the shift of consumers to prosumers, and with the strains or the stress this gives to the existing distribution and transmission grid, it is important to look at local to balance our energy production, energy demand on a local level. And this means that we're heading into this paradigm shift where we're going from a centralized energy model and also a market model which is based on this central energy model to a more flexible, dynamic, prosumer-centric energy model. And I believe that initiatives like local energy communities, citizen renewable energy communities, will play a significant role in this paradigm shift. That being said, now we should look at who are these consumers of energy. In this diagram, you see 5 different colors, but I like to talk about 3 clusters. The first one is the industry cluster. So I'm taking the non-energy consumption and the industry together as one industry cluster, because the non-energy consumption is all about petroleum products, natural gas that are feedstock for the industry, for their products. We have the transportation sector, and then we have the domestic and services and assimilated. I like to take those 2 also together and call it the buildings cluster. Those 34% with services and assimilated. I mean, it's about public buildings, about offices, and each of these 3 clusters, industry, transportation, and buildings, they face their own specific challenges due to their own specific context, obviously. If you look at industry, for example, they're doing today already a lot in energy efficiency. In Belgium, we have something like energiebeleidsovereenkomst. It's something like energy covenants, in which the industry is engaging themselves in energy efficiency projects in their processes. But they face very big challenges that they're not ready to tackle yet today. One of them is the feedstock, the massive feedstock that they use that consists of petroleum products, natural gas, for which they do not have alternatives today on the scale that they need. Yes, there are bio-based initiatives, or you can use CCU, and from the CO2 you go to methanol and other feedstock products, but they're not readily available on a large scale to implement them on an economical, feasible way. And this is just a market at the industry level that is not ready yet to make this transition. They have this hurdle to take. If you look at transportation, we have different kinds of transportations, obviously. If you look at aviation, shipping, they face similar kind of challenges as industry in the sense that the technologies that are available are not yet readily available on the scale that makes it economical feasible for these sectors to implement them on a large scale. I'm talking about hydrogen for example, for shipping or methanol or biodiesel. But if we're looking at transportation and we're looking at passenger cars, then we see that the past 2 to 3 years, the evolution or the acceleration of battery electric cars is really accelerating. And this is due to different kind of factors. The first one is car manufacturers that are finally picking up the production of battery electric cars. It's also due to the fact that more and more charging stations are publicly available. But it's also due to the fact that we have some solid policy around zero-emission mobility, cities that have their low-emission zones, company cars that in Belgium have to be zero emission starting from 2026. This gives a very clear policy on where we're going through. And the manufacturers are responding, and the market is preparing itself to be there, to be ready in the next few years to roll out battery electric vehicles on a larger scale than today. But if we look at the building sectors, this is, for me, this is the 2 together, services and simulated and domestic. It's 34% of our final energy consumption. There is already a lot of technology available to transform these buildings and existing buildings into more energy efficient buildings, that we have a lot of technology available for efficient heating and cooling systems. And we do see a lot of developers that are very ambitious in their greenfield developments to make it the most sustainable development. But the real challenge today is the already existing built environment. And that is, in my opinion, why we do not see this acceleration of transition in this sector of buildings. Main focus is at very thorough renovation and or new buildings, but if we're looking at the already existing built environment, that is where we can find the scale that we need to have a significant impact on the energy transition. But that is also where we find the biggest challenges to overcome. I'm talking about a mix of the socioeconomic mix. I'm talking about the spatial challenges that come along. I'm talking about the fact that we have all these different homeowners, and how are we going to do this in an organized manner. Therefore, I want to show you or bring you this time not to Sweden, but to Ghent. Ghent is a city, I think, 35 or 40 kilometers to the southeast of where we are right now. And we got this question of the city of Ghent to build a roadmap, an energy strategy for a specific district Muiden-Meulenstede in Ghent, to make it fossil-free in 2050. And why did they pick this beautiful district? Because it has the typical socioeconomic mix, as you can find in typical neighborhoods in Ghent. It has very clear boundaries due to the water it's surrounding. It is on the sides you have some industry, you have some offices. I think 50% of the buildings is built before 1950, and just at the north of this district you find the North Sea port. And if you look here on the red networks you find there, those are two existing district heating networks in the city of Ghent. The most south is Ivago, which is a waste incinerator, and then you have GDFL. I think that this is heat coming from a cogeneration installation. So they asked us, okay, we want a plan to make Muiden-Meulenstede fossil-free in 2050. How are we going to do this with this mix of buildings, with this socioeconomic mix, with industry? How are we going to do this? And before we started, we considered that we had to take in mind three major issues when it comes to energy transition on this level. So we're going on a district level. And the first one, that energy transition is also a spatial challenge. For example, you cannot use the same space two times. Is there enough room under the street to implement yet another infrastructure, a district heating network, for example? Is this spatially is the right location to add new wind turbines? Do we have space for a stationary battery for on a neighborhood scale? So energy transition is also a spatial challenge. Second, we have the financial challenge. First of all, this new infrastructure like a district heating network. To give you an example, investing in a district heating network in such an urbanized place like Muiden-Meulenstede would cost 1,500, maybe 2,000 euros per meter, which is a high investment on a long term. And it's very hard to compete today with the existing gas infrastructure and the gas prices. At the other hand, we talked about the paradigm shift a few slides ago. It's not only a financial challenge, I think, but there are also some financial opportunities when we evolve to a more flexible and more dynamic energy market. And we already see organizations or stakeholders like cooperatives here in Belgium that are interested in projects like this. But for them, it's important not only to invest in the district heating network, but also to have some control in the energy balancing of the whole ecosystem of the district. because there they see their business case in the future flexibility market. And then you have a third issue, and that is making the right technological choice, and not only for today, but also for the future. Making sure that you're not, by making a certain choice, that you get a lock-in. Also weighing optimize of production off against optimizing energy use. Like I said, 50% of the buildings at Muiden are older than 1950. And these are all independent homeowners. If we all ask them to have this A-level renovation, energy efficiency building, what are we expecting? What are we asking these homeowners financially to invest in their homes? And we have to look at the social benefits, but also the social costs of the whole picture of the district. And maybe if the surroundings offer some opportunities like waste heat, maybe it's more interesting in specific areas in your district to work in a collective system, then you should go for this collective system. And meaning that, okay, those houses should not maybe renovate to the same energy efficiency as other parts of the district. So we started to put the puzzle together. We start with the modeling of the current and also the future energy demand of the district, working with a few scenarios. Always, of course, taking into account the urban and spatial development of the district itself. What are the future plans and what is the future vision of this district? Are there maybe important public infrastructural works planned? All these things we have to take into account. Also, for example, in this case, there was waste heat available in the district of Muiden, but how long is this waste heat guaranteed? Because those are all questions that we have to take into account in our energy strategy. Next, we have the technology choices, heat, cooling systems, and then the distribution network, storage of energy. And this all combined should lead us to the roadmap, the energy strategy for Muiden. This is a visualization of our modeling of the energy demand. This is actually another district in Ghent. This is Mariakerke, but it's in a more clear visualization than Muiden. On the left, you have the energy demand of the buildings as it is today, the current situation, which is based on the actual use of electricity and natural gas in most cases. And on the far right, you have a scenario where you see a significant impact and decrease of the overall energy consumption of the district. But this is when we go for thorough renovation of all the buildings in this district. And we have to ask ourselves the question, is this a realistic scenario? And it's the same thing I said earlier. What are we asking of our homeowners, and what is realistic to expect to invest in the renovation of your house? And that's why we have this middle scenario, which is for us a more realistic scenario, where we're looking at the density of energy demand, of heat demand, when you reach a certain density in an area of your district that is high enough that reaches a certain threshold of energy demand, then it may be more feasible to install a collective system. And if you have waste heats on higher temperatures close by, then you can even feed it with these higher temperatures, and you don't have a need to invest so much in the buildings itself. So you don't have a need to renovate the building and change the heating systems to underfloor heating and to have insulation everywhere. So this is a scenario. The middle scenario is a scenario where all these parameters come together, and we look at what is realistic and what is the best choice on a societal level for this area in the district. We looked at, for Møller at three main technologies. The first is electrification, which is an individual decarbonization. The second is district heating, our collective approach. And the third is green gas, where we were looking into how can we reuse the existing gas network for green hydrogen or syngas. It soon turned out that this third scenario, green gas, was way too expensive compared to the other two. So for the further of our energy strategy, we focused on electrification and district heating. And at the start, we looked at, okay, what if we apply electrification for the whole district, or what if we apply district heating at the whole district? And from there on, we started changing parameters, started looking at what if we use, you have this heat demand density over there, you have the source of waste heat over there, what is the impact of an extra kilometer of district heating network financially. So we put all these parameters together and we came up with in our opinion, a realistic energy transition scenario for Møller, where as you can see, we have the red part is where we're going to install, or where we suggest they install a collective system and district heating system, which is fed by a nearby industry with waste heat. This will also follow the main road of Møller, which will be in the near future totally renovated and will also get, for a small part, another function. So this gave also an opportunity to use this corridor as a backbone for the district heating network. And then on the white, for you it's more black, but those parts of Møller there we're going for, or there we suggest they should go for individual approach of as a switch to decarbonization, because it's the cost to also go there with a district heating network does not weigh out to the cost of the individual measures. So together with some stakeholder workshops, we were able to make a roadmap how to achieve this situation in 2050. But for us, this is not where it should end. For us, this is the basis of an energy strategy. What you should add to this is an extra layer of the communication between all these different aspects in your energy ecosystem of your district. And this is back the paradigm shift where I talked about earlier. We have to, on a local scale, balance production and demand. We also have all these battery electric cars that are coming for us. It's not a good idea to have them all start charging at 6 or 7 o'clock when people come home from work at the same time. At the other hand, how can we maybe integrate them as a flexibility instrument in our energy ecosystem with V2G, vehicle-to-grid technology, and load balancing, and how can we use them for peak shaving? This is the flexibility that is going to be needed in the prosumer-centric new energy model which we're going to evolve to. But this also demands a lot of monitoring, data, monitoring of production, consumption, performances of buildings, and all these things have to communicate with each other. And if this is not complex enough, then you also have the layer of the consumer itself, who has today its expectation of comfort, who is used to the availability of energy. So this is the consumer is another layer of complexity that we should always take into account when we are developing an energy transition. an energy transition strategy. So for me, what is most important is that if you want to reach or achieve a significant impact in the sector of buildings, then we have to also focus not on the building itself, but also on the community or, excuse me, more district level, which is very important. And the choices that we are making should be choices that are not only sensible today, but should also be choices that are sensible in the future and in regard to the transition that we're going through. And I want to illustrate this with a last example, and this is the little town of Visby, which is close to Stockholm, so back to Sweden. And this is a town where in the 80s they had to renovate their public infrastructures, so roads and sewage works. But the local authority had the idea in the 80s, well, we're breaking up the roads today, we're putting new sewage systems in the ground. Maybe it's also a good opportunity to already put some conduits that can be waiting underground, so like empty pipes that can be used later in the ground. We don't know yet what we're going to use them for, but maybe it's a good idea. So they did this. It was a little higher investment cost, but lo and behold, 25 years later, the whole telecom infrastructure of the center had to be renewed, and they could do this in a non-invasive manner and a more cost-efficient way. So this is a perfect example of how you can make good choices, sensible choices for the future. And with this, because you all look very hungry, I'd like to conclude my presentation, and thank you for your attention.
Thank